So let's go back, and we're going to, in this video, discuss interfaces because it's kind of unavoidable at this point. This slide says the Java provides a list interface as part of its java.util API. All right? And so it's this whole thing. Classes implement the list interface, provide the functionality of an index data structure, and offer many more operations. So it kind of requires us to understand what an interface is. And somewhat coincidentally, a interface kind of is a list. Now, it's a to-do list, actually. It's a to-do list for what you need to be something. That may not make sense, so probably doesn't actually make sense right now. So let me go ahead and explain. All right, we've got here, there's two types of relationships you can have in Java with other classes, okay? And you'll notice here that I've organized it, and now I'm putting it in the proper repo. You can now see so what that means is that now you can see my code on the link that I put up on the class websites. You just have to click on the link, and all our code will be in dstruct, short for data structures. Okay? So public class reptile extends animal. This establishes a relationship. A reptile is an animal. Awesome. So a reptile is an animal. An animal is a object. That's kind of an implicit is a relationship. Classes can also has a relationship. A animal has a name. So occasionally, though, we want something to be something, but we aren't really sure how to build that original thing. Also, what if we want to be a lot of different things? So let's go ahead and let me go ahead and create a concrete example. Right? I'm going to make a shape class. All right? And instead of making a class, though, I'm going to select down here interface. Okay? And an interface is exactly like writing an interface is so much easier than writing a class. It resembles a class greatly. Public interface shape instead of public class shape. Okay? Now, there are rules about what you can put in an interface. The only thing you can put in here are method stubs, and you'll see what that means in a second, and I think final variables. Like I can't put, for instance, over here, private int x. That's going to start yelling at me. Modifier private not allowed here. Okay. Int x, maybe? No. Ooh. Variable x might not have been initialized, so you have to have So I have to put things here. Final is redundant, right? Notice that it was italicized. That was kind of a hint to me that this would be that putting x here, any variable I put in an interface, it's automatically final. Can't change it. It's a constant. Okay, so you can put constants here, and you can only put methods here. So why is an interface appropriate for a shape? Well, shapes are these things, but every shape behaves very differently. In terms of calculating what we care about for shapes, which generally when we calculate shapes in something like geometry class, we calculate two things. We calculate the perimeter. All right. Notice how I'm writing that. Public void get area. Well, assuming I can spell. So public. It's warning me that's just redundant. I don't have to put that there. That's fine. I'm going to keep it there anyway, just simply for the sake of looking fine. Public void get perimeter and public void get area, right? So the idea here is that everything that is a shape, be it a square, a rectangle, a circle, they all share something in common. They share calculating perimeters, right? Every shape has a perimeter, and every shape has an area. They both have a way to calculate a shape in an area. And what an interface does, by creating an interface, I can say that these things are all shapes, even though they're going to be each implementing the get perimeter and get area method very, very, very differently, right? A circle acts very differently than implementing a square. Okay, so and I keep using that word implement. You'll see in a minute. But what this is that we've created a list to say that if you create a class and you want that class to be considered a shape, then these are the things that it must do to be a shape. You'll see that in a second. You have to implement these methods because the way they need to be implemented. They need to be implemented. Oh wait, hold on a second. Should make these doubles, right? Because calculating a perimeter, that should return something. So my bad there. Okay, so let's go ahead and see how we use these things, right? I'm going to create a very basic shape, a square, right? So a square is a type of shape. But rather than extending an interface, we implement an interface. Now you can implement as many interfaces as you want. Why? Well, because these are just method stubs. They have no content. In fact, if I try to put content in it, it's going to give me an error. Interface abstract methods cannot have a body. What's an abstract method? Well, these things are abstract methods. They're methods that basically are an abstract method is a method that must be written by whoever's inheriting me, by whoever is a child class of mine, right? I could put abstract right here, but it's redundant. So you can make any method, by the way, abstract, saying, hey, public abstract void eat, right? I'll get to that error in just a second, okay? And that would tell the my child class, hey, in order to be considered an animal, you need to finish up this eat method. You need to define a way for you to eat. But we can't put abstract here because this is an abstract class. You can only put abstract methods in abstract classes or interfaces. Okay, public abstract void, and then I would have to remove this body in order to do that. The big thing here is that you cannot implement, since these methods aren't defined, you can't implement the class. I'll show you in a second. So square is a type of shape. Public class square implements shape. All right. And notice that we've got an error already. Square must either be declared abstract or it must implement the abstract methods from our parent. So let's go ahead and write those methods, right? Double. So squares, what defines them? It's the side length, right? Double side length is equal to double side length. We'll go ahead and alt insert. All right. Alt insert constructor. And we'll let this automatically implement the methods, right? And that's all it needs to be done to just simply squelch that error, right? We've implemented get perimeter, returns 0, and get area, returns 0. It doesn't have to be implemented correctly, but we've implemented shape. We've fulfilled the requirements we needed to be a shape, which is that all shapes have a get perimeter and a get area method, right? Now let's go ahead and actually bother implementing these correctly. So return side length times 4 for the perimeter, right? And return side length times side length, right? Something squared to get the area of that, right? So we've established that a square is a shape, right? Now there are many different types of shapes, right? Okay. Why are we getting an error still? I don't know. I don't think we actually have an error. I just think it's being slow at looking at it. All right, let's go ahead and move. Let's create another shape, a rectangle. Implements. This is also a shape. And Control I believe, was to implement those. Yep, this my computer caught up. It removed the error. Okay. And let's go ahead and build a rectangle, right? Rectangles have a double length, double width. And the way we calculate their perimeters is by returning length times 2 plus width times 2. And the area in this case would be length times width, right? A rectangle is a shape, and as a result, you have a way of figuring out what the perimeter is and what the area is. That's what you need to be a shape. You need to have a way to figure out what your perimeter is and your area is. That's what we've defined, right? And because these are abstract methods, we don't define them here. In fact, it gives us an error if we try to define them here. Okay, so what does this? So there's two big uses of interfaces here. The first is that basically we can use this for a blueprint for writing a class. That makes that really nice. So interfaces act as a blueprint. What I need to write this something of this type. And the other use is much like what we had with the animal. We can use interfaces with polymorphism. Let's go ahead and write one more shape very quickly, a circle, just to knock this out, right? And you might want to try actually pause the video right here and try implementing a circle yourself. Go ahead. Right? I'll give you this bit, right? Okay, so go ahead and try implementing a circle yourself. You're still watching. Go. Do it. I'm sure it will be a worthwhile exercise. Alright, so I'm just going to pretend you actually did that, and we're back. Alright, so first let's go ahead and we've got what defines a circle. A circle is defined by its radius, right? Double radius. Right? So let's go ahead and insert a constructor, right? And I'm just auto-generating the constructors right here, just simply so we can write these super quickly. And then to implement the methods, right? Let's go ahead and we needed a public double get area, right? So the area of a circle is pi r squared, right? Math.pi, or you could have done 3.141, and so on and such. So pi times the radius squared, right? So radius times the radius. And the get perimeter could have been should have been 2 pi r. All right. So now, with this example, what I can do, let's go ahead and just make a driver class. Shape example public static void main. If you're running NetBeans, you can do that same trick, PSVM, and hit tab, and it will generate a public static void main for you. Okay. Similar in NetBeans, you can do SOUT and hit tab. I don't know if Eclipse has those types. If they do, I've never hit them. It's part of the reason I made the switch to NetBeans to Eclipse. No, IntelliJ. That one. All right. So, shape example. So let's go ahead and we can do something similar, right? Shape. So first off, because we've got an interface here, I cannot. The big thing about interfaces, I cannot do this. Shape S is equal to a new shape. Why not? Because it's not. Essentially, these are. I have to write these methods. They aren't written. It's an unfinished program. I can't implement a unfinished program. That's what it means by saying it's an abstract class. It's abstract. It cannot be instantiated. It means that as an interface, it's abstract. It doesn't really. The code for it really doesn't exist. The code. You know what the code is that you have to write, but it's not written yet. So you can't implement an interface like that. You can, however, like say that a new circle, right, with a radius of 5.0, that this is, right, we can store a circle is a type of shape, so we can store it in the shape variable, right? And then we can figure out what its circumference is by doing, which is, the rate, which is the perimeter. And run. And that's about 2 pi r over there. So, and similarly, we can have a collection of shapes, right? Shape array shapes is equal to new shape array, right? We can have an array of these interfaces. Let's go ahead and say, let's just create 3 of them. Shapes 0 is equal to new circle, right? Radius 4 because I hit that instead of 5. Shapes 1 is equal to a new square. Shapes 2 is equal to new rectangle. 3, 4. And then we can do a for each loop, right? Let me go ahead and write it manually. For each shape in shapes. Now you'll notice that I use that paradigm a lot. For singular for singular of the same name as the class type in plural. So for each individual shape in the shape array, shape dot get area, shape dot get perimeter. Okay, so that is, and so now each of those shapes is calculated in the correct manner because this is the power of polymorphism. It allows each shape to be treated as the type of shape once we get to it. As the appropriate type of shape once we get to it. Alright, so that's it for this lecture, for this video. Next, we're going to tackle generics as part of explaining how arrays work. But, yeah, actually I'll create one last video after this just to talk about the list array, or the list interface.